Hello, this is Jeffrey Frankel with Solutions in Chemistry. Today I'm going to deal with quantitative and stoichiometry questions in IB Chemistry Paper 2. With my techniques you can solve these questions fast and correctly. Elemental analysis of compounds can be given in questions in different formats, and I find students have difficulties with these different formats. This method, giving you a percentage of carbon and a percentage of hydrogen, is the, shall we say, the standard method. But there are other ways of presenting this information. I will show you how to answer the question when the analysis is given to you as a percentage, and then I will show you how to answer the question when it's given to you in other forms. The first thing to notice is that you're told it's an organic compound, and you're also told that the percentage of carbon is 40% and the percentage of hydrogen is 6.7%. You can assume, and usually it's actually told you, but you can assume that the rest of the material is oxygen. So the thing to do would be to write down the carbon, 40.0, the hydrogen, 6.7, and the rest must be oxygen. And you add those two up, subtract from 100, and you get 53.3. As I said, usually you're told that the rest is oxygen. Then you divide by the atomic masses, which is 12.01 there, 1.01 and 16.0. Now, if this were a paper 1 question, I would just use 12 and 1. However, since it's a paper 2 question, I would advise you to use the numbers given in the periodic table of the data booklet, which is 12.01 for carbon and 1.01 for hydrogen, unless you're told anything different. Sometimes at the end of a question they will give you the atomic masses, and they will say something like atomic mass of carbon C equals 12.01, etc., etc. In this case, nothing is mentioned, so use what's in the periodic table. So when you calculate this, you get 3.33, and since there's 2 decimal places there, I would stick 2 decimal places at 6.63, and this is 3.33, and you can immediately see the ratio is 1 to 1. The empirical formula is equals CH2O. They have determined the molecular mass, or the molar mass, and they found it to be 180. So you have to determine what is the molecular formula. If the empirical formula is this, CH2O, then the molar mass of that CH2O is 12 plus 2 plus 16. Carbon plus 2 hydrogens plus oxygen. In this situation, I would just keep to 12 for carbon and 1 for hydrogen, especially since they haven't given you anything after the decimal point. They've just said 180. So that comes to 12, 14, that comes to 30. Then take their 180 and divide it by 30, and you get 6. Therefore, the molecular formula equals CH2O 6 times, or preferably C6H12O6. That is the answer. This is exactly the same chemical, and this would be the original data from which those percentages were calculated. We can convert those masses into percentages, but we don't have to. We can use them directly as they are. What you need to do is you say carbon 0.52, hydrogen 0.087, and then oxygen. And of course the value of oxygen is simply the difference between 1.30 grams and these two. And that is oxygen equals 1.3 0 minus 0.52 plus 0.087, which equals 0.69. 0.69. And you go through the same process as before. You divide by 12.01 the mass of atomic mass of carbon, 1.01 the atomic mass of hydrogen, and 16 the atomic mass of oxygen. For convenience, I'm going to multiply that by 100. I'll multiply that by 100 and then multiply that by 100. Now you may decide you don't need to do that. That's your choice. But I'm going to do that because I find looking at the ratios are so much easier when they are numbers rather than small decimals. You get here 4.33, 8.61 and 4.31, and that comes to 1, 2, 1. If I didn't have the hundreds there, I would still get this ratio 1, 2, 1, except that this would be 100th of that, that would be 100th, and that would be 100th. So the answer is still CH2O, which is the same as before. So that's another way of showing you the information. This is another way the information can be presented to you. Obviously it's not the same chemical. I'll show you how to deal with this particular situation where you're simply given the percentage of one element. I would simply write down, and I would turn this into grams of iron is present in 100 grams of hemoglobin. Converted the percentage into grams, and 0.335 grams of iron is present in 100 grams of hemoglobin, which is what they say. Then I'll go to 1 gram of iron is present in, and that's 100 divided by 0.335, which equals 298.5 grams of hemoglobin. They ask for 1 atom of iron. The atomic mass of iron is 55.85 G, and that is present in 298.5 times 55.85, which equals 16,672 grams. Now this is only accurate to 3 significant figures. That's the least accurate of the 2 numbers. 3 significant figures there and 4 significant figures there. So what I'm going to do is I'm going to make this accurate to 3 significant figures. 1, 2, 3. So I'll make it 16,700 grams. And that is the answer. If hemoglobin contains 1 atom of iron, then its molar mass is 16,700. If it contains 4 atoms of iron, now I'm not a biochemist, but I understand hemoglobin does contain 4 atoms of iron, so you simply multiply that number 4 times 55.85 grams of iron is present in 4 times 16,672. I go back to the more accurate number in order to do this calculation. It may not be necessary, but I go back to that number. 66,688 grams. And then I change it to 3 significant figures, which equals 66,700 grams. And that is the molar mass if it contains 4 atoms of iron. I will be doing more YouTube videos on Paper 2 questions, so subscribe to my channel and you will be notified.